So this is the remediation for the fundamental theorem of algebra. And there's quite a few ideas going into this section, so make sure you hit all of them on your remediation and, of course, complete the remediation. So, first idea is I'm going to give you a factored form polynomial, and you're going to tell me all of the zeros. So, the zeros would be if you take your factors and you set them equal to 0. That would be the algebraic way to find all of these solutions. So, like for instance right here, x minus 13 equals 0 would give you a 0 at 13. Now, if you want to get real fancy, you could write it as an ordered pair, 13, 0. So there's another 0 right here. When you set this equal to 0, f x equals 1. So again, you could write it as an ordered pair. And then here, my microphone a little closer. Here, you'd get x equals negative 1. So again, you could write your ordered pair as negative 1, 0. I'm not going to count you wrong if you don't write them as ordered pairs, but it would be nice. All right, the next section. This is where normally we'd use a calculator to kind of help us out, but I went ahead and gave you, in case you don't have a calculator at home, I gave you the polynomial, and then I gave you a couple of places where you would see an x-intercept. So you are going to use synthetic division to knock down this higher degree polynomial to something manageable like a quadratic. So let's look at number 3. I'm going to set up synthetic division with the coefficients. Make sure we're not skipping any coefficients. Oh, and we are. Be careful. There's a plus 0 missing on the end. There's no constant. So your coefficients are 1 and 2 and negative 9, negative 18, and then don't forget the 0 on the end. Now in this little half box for synthetic division, you can choose whichever one you want to start with. Now this time, remember, they're not factors. They're actual zeros. So you're going to put exactly negative 3 into that box. And then you set up your synthetic, that's ugly, division. Bringing down your first term. Remember, if you're below the line here, you're multiplying. If you're above the line, you're adding. So 1 times negative 3 is negative 3. And then if you were to add those up, you get a negative 1. And then keep going. So a negative 1 times negative 3 is a 3. And if you were to add up that column, you get a negative 6. Negative 6 times negative 3 is a positive 18. And if you add up that column, you get a 0. And 0 times negative 3 is still a 0. 0 plus 0 is 0. Now, this is great news, because when you're doing this problem, you need to make sure that the remainder comes out to 0. That if it doesn't, one of two things happen. Either you set it up wrong or computed it wrong, or I misled you and gave you something that wasn't a 0. But that wasn't the case. So now, let's keep going. And we're going to do another series of division, synthetic division, where you take the next x-intercept that I gave you. So this time, using this suppressed polynomial, the smaller one, ignore the remainder. Everything else we can do synthetic division again with the negative 2. So bring down your coefficient again. And then negative 1 times negative 2 is negative 2. Then we're going to add these up. And you get a negative 3. Negative 3 times negative 2 is a 6. And it adds up to a 0. And then once again, you get 0, 0, 0. Alright, cool. So, we do end up with a remainder of 0. So I know we've done some good work. And then it says factor to find all the rest of the zeros. So what you have here remaining is your smaller polynomial that we should be able to factor because it's a quadratic now. Remember, you took an x to the 4th and you knocked it down twice. So this is a 1x squared minus 3x. I'm not going to say plus 0 because that's kind of weird. Okay, so this is the polynomial that I want you to factor with me. So common factor of x taken out, x times x minus 3. And then if you solve, this one would be easy, x equals 0. And then if you solved x minus 3 equals 0, you're going to get x equals 3. So there's 1, 2, and then the other 2 solutions I already gave you. 3, 4 solutions. I think that's all they wanted me to do there. So the answer key's on the back. If you're worried about like what they really want from you, they want the zeros. And it does say to factor everything. So I'm kind of running out of room, but all of these zeros I could throw back into factored form of my polynomial. So x equals 0, the factor for him looks like x. X equals 3, if I go back into a factor, it's x minus 3. And then x equals negative 2 gives you a factor of x plus 2. And now I'm really out of room. X equals negative 3 gives you a factor of x plus 3. So this is factored form of your polynomial. And these red things I kind of marked off are all of the x-intercepts. So, those are a hoot. This next section, I give you the x-intercepts, and I want you to write a version of a factored form polynomial and assume the least coefficient possible. So don't do any extra work, basically. So here, I give you all the zeros, put them back in as factors. You can name it whatever you want. I'm going to name this one p of x. So if you have an x-intercept at 0, or a 0 at 0, his factor you could say is x minus 0, but most people just call that an x. The other x-intercept I gave you is x equals 3. And if I go backwards and write that as a factor, that would be x minus 3. And then the third x-intercept is x equals 4. If I go back and write that as a factor, that would be x minus 4. So basically we're working backwards. I'm giving you the solutions, and I want you to back up and write them in polynomial factored form. Alright, now this one gets a little more complicated. They introduce the idea of conjugates. So if you have a complex solution, they have to come in complex conjugate pairs. So if a plus bi shows up in your list, then you're supposed to know that a minus bi is also there. So when I look at this guy right here, 1 minus 3i, I notice they don't list out 1 plus 3i, which would be his conjugate. So find any additional zeros. So there's also a 0 at 1 plus 3i. And then similarly, this guy, negative 2i, which you can think of it as 0 minus 2i, his conjugate would be 0 plus 2i. So what I'm looking for you to come up with on those questions, who are the missing zeros that they didn't have to tell me because I'm supposed to know all about this conjugate rule? Now on this one, we're going to put these thoughts together. I'm going to give you some zeros, and you also have to watch out for conjugates. So 1 is not an imaginary number, so we'll just leave 1 as 1. But then it says I is one of your x-intercepts. So what that means is we also have a negative I. They didn't tell me that. I'm supposed to know that. And you don't have to do extra work here. All you're going to do is set it up in factored form. So it's kind of like number 5. If they tell me x equals 1 is one of my solutions, the factor for that is written as x minus 1. If they told me x equals I is a solution, for Algebra 2 students, I'd like you to write that as x minus I. And then we came up with this one. X equals negative I is another solution that we're supposed to know. So his factor would be x plus I. So you're going to see that good twin, evil twin conjugate thing pop up in your math every time that you have a complex solution. Don't do any extra work on that one, guys. Just leave it just like that. All right, good luck on your retake.